Lesson 12-1, area of parallelograms, triangles, and trapezoids. And in this lesson, you'll find areas of parallelograms, triangles, and trapezoids. Okay, so let's take a look at this rectangle, which has a width of 4 centimeters and a length of 6 centimeters. And if you notice, if I draw this rectangle again, okay, right here, this is our rectangle, and I move this triangle, this side of my rectangle, to the other side of the rectangle on this side, it will form a parallelogram. And if you also notice, the area of this rectangle is 24 square centimeters, and if you find the area of this particular parallelogram, it is also 24 square centimeters. So basically, the area of this rectangle is the same as the area of this parallelogram. Okay, so when we want to find the area of this rectangle, we simply multiply the width and the length. Okay, and this is also known as the base, and this is also known as the height. So just like in a parallelogram, you can also multiply the base and the height of a parallelogram to find its area. So the modeling activity above suggests that you can find the area of the parallelogram by multiplying the measures of the base and the height. The base can be the side of the parallelogram. The height is the length of an altitude. Okay, a line segment perpendicular to the base with endpoints on the base and the side opposite the base. So this is what it means right here. This is your base and this is your altitude, which is also considered our height. And in that particular case, okay, it is always perpendicular to the base. So when you talk about the altitude is a line segment again, okay, perpendicular to the base. This is your base and this is your altitude right here, which is also considered to be your height, okay, with endpoints on the base and the side opposite the base. So you need to remember this particular line right here, that the height is always perpendicular to the base. Okay, so when you're looking for the height, okay, you're always looking for a line that is always perpendicular to the base. So the height is always perpendicular to the base, or it creates right angles with the base. Okay, so let's take a look at a formula for area of parallelogram. So if a parallelogram has base B units and a height of H units, then area A is base times height square units, or in symbols, area equals BH. Okay, so base times height. So let's find the area of each parallelogram in these two examples, example A and example B. So you have parallelogram A with a height of 4 centimeters and a width of, a base of 3 centimeters. And if you notice, okay, you look at the base is right here. The base is always perpendicular to the, the height is always perpendicular to the base. If this is your base, oh, that's too thin, let's make it thicker, okay, right here. So if this is our base right here, and this is our height, okay, our height is always perpendicular to the base because it creates that right triangle with our base. Okay, so knowing that, we first find that the base is 3 centimeters and the height is 4 centimeters. We will first write down the formula for area of parallelogram, and then we substitute the values for base and height, and then we end up with 12. So in this case, the area is 12 square centimeters. Make sure you have the right unit. In this case, it's square units, or in this case, square centimeters. Okay, let's take a look at this example, 1B. So again, you have your parallelogram, and this is your base. Why is this your base? Because this is also perpendicular to your height, which is 6.3 inches. So if 8.4 is your base, then 6.3 will be your height because they're perpendicular to each other. So again, we've used the formula for base times height. Substitute the values for 8.4 and 6.3 for base and height. Multiply those two, you end up with 52.92. So the area of this parallelogram is about 53 square inches. Okay. Now let's take a look at another one. if you draw a diagonal in a parallelogram, you form two congruent triangles. So when you look at this particular parallelogram and you draw a diagonal, remember what a diagonal is. A diagonal is a line segment that connects non-two adjacent vertices. So when you talk about this one, if I'm going to draw a diagonal, okay, this is my vertex and I'm going to draw my diagonal there. Okay, so the area of each triangle is half the area of the parallelogram. So you have two triangles that have been formed. Okay, this triangle and that triangle, triangle ABD and triangle CDB, okay, and they're congruent to each other. And if I take out that triangle, okay, right there, this is what you get. So this is now your parallelogram. Dividing it by the diagonal, you end up with two congruent triangles. And if you have a parallelogram with a base of 8 and a height of 4, we can find the area of our triangle. Okay, because the area of a triangle, if you recall, is equal to 1/2 base times height. So the area of triangle ABD, okay, is equal to 1/2, okay, times 32, or 16 square units. Okay, so in words, when you want to find the area of a triangle, if the triangle has base B units and a height of H units, the area of a triangle is 1/2 base times height square units, or area equals 1/2 base times height. So with a parallelogram, you can derive the area of a triangle, because the area of a triangle is half the area of your parallelogram. Okay? So as with a parallelogram, you can use any side of the triangle as a base. Okay? The height is the length of the corresponding altitude, the length segment perpendicular to the base from the opposite vertex. Okay? So if you let's take a look at this triangle right here. Okay? You notice that if your base is AC, which is this one, our height will be BD, which is that one. Why? Because this is your base, and your height is perpendicular to our base as indicated by the right angle. Okay? And if you also notice, if we find another base, let's say our base is AB, this one right here, okay, we know that our height will be CE because it is perpendicular to our base AB. Okay, and finally, if we make our base BC right here, we can make AF our height because AF is perpendicular to CB. Okay, now let's take this one step further. Let's say you have a triangle such as this one. Okay, if you find your height or your base to be NQ right here, our height would be PR because that is perpendicular to our base. The problem is, what if we make, okay, NR our base? If NR is our base, that means, okay, we need to find a line segment that is perpendicular to our base, which is QS, and this is QS right here. So if you notice, that's NR, okay, and we found a line QS that is perpendicular to our base. Okay, so we simply extend, okay, side NR to S. So side NR has been extended to S. Okay, and that's how we found a line that's perpendicular to our base NR. Okay, and lastly, if we make QR our base, so this is QR, our base, we need to extend the triangle again on the other side this time. So we simply extend segment QR to T so that we can create a line that's perpendicular to QR, which is NT. So in this case, our base is QR. We're going to take the length of QR, but our height would be NT. Okay? So if you notice, if you want to find the base and the altitude, okay, Notice that an altitude can be outside the triangle. So your height can be outside the triangle for as long as it's perpendicular to your base. Okay? So let's move on to example number 2. We want to find the area of each of these triangles. Okay, and example 2A is easy enough because you know that there is, you know what the height is right away because of that little sign here which indicates a right angle. You know that 3 centimeters is perpendicular to 4 centimeters. So you know right away that this is your base, 4 centimeters is your base, and 3 centimeters is your height. So the base is 4 centimeters long, the height is 3 centimeters long. Okay, and then we apply the formula for a triangle. Area equals 1/2 base times height, which is the formula for a triangle. Substitute the values base and height, 4 and 3, so it's 1/2 times 4 times 3. And then this becomes 1/2 times 12, so area is 6. Okay, so the area of this particular triangle is 6 square centimeters. So in example 2B, it's not so evident what the base is, so we need to extend our base. Okay, so that it will have a line that's perpendicular to it. So 5.4 is your base. Now remember though, when you say 5.4 centimeters, 5.4 starts from here and ends here. It does not end on this side. So 5.4 centimeters is simply the length of that side of the triangle, and 6 centimeters is your height. So from there, we use the formula 1/2 base times height, substitute the values of 5.4 and 6 centimeters. Okay, we end up with 6.2, and the area of this triangle is 16.2 square centimeters. Okay, and let's move on to our last polygon that we're going to talk about in this section, which are trapezoids. Okay, so if you recall, okay, the definition of a trapezoid is something like this. But before that, you can use triangles to find the area of a trapezoid. Remember, a trapezoid is a quadrilateral with exactly 2 parallel sides called bases. So this is your trapezoid. It's a quadrilateral. It's a 4-sided figure with 2 bases, okay, that are parallel to each other. The height is the length of the altitude, same here. Line segment perpendicular to both bases with endpoints on both baselines. So the endpoint is here, the endpoint is over there. And same as what we talked about, the height is always perpendicular to the base. Okay? So the height is always perpendicular to the base. And if you analyze this trapezoid right here, okay, the triangles, triangle PQS right here, and triangle QRS right there, okay, the altitudes of these triangles, okay, segment QT right there and segment SV right there are congruent. Okay, both are H units long. The base of triangle PQS is segment PS, and the base of triangle QRS is segment QR. They are both, segment PS is A units long, and segment QR is B units long. So if we analyze that, and if we draw 2 triangles like that, we know for a fact that if you get this triangle and add the area of this triangle, we end up with the area of the trapezoid. Okay, so that's what we want to find out. Okay, exactly that. So what we want to do is the area of a trapezoid PQRS will be equal to the area of triangle PQS, that's like what I said, plus the area of triangle QRS. Okay, and if we substitute, if we want to find the area of PQS, okay, remember the area of a triangle, okay, is equal to 1/2 base times height. So in triangle PQS, our base is PS and our height is QT. So if we substitute that, area of PQS is 1/2 times AH because PS has a length of A, okay, and this is our height, which is QT. And we know for a fact that QT is the same as VS, and that's the reason why our height is H. And going to our triangle QRS, okay, the area, our base would be b units long, okay, as indicated by the b right here. You see, moving right, the b right there, okay, and we still have the height as h, so this becomes 1/2 times b times h, and if you use the distributive property, you end up with 1/2 h times a plus b, which gives us the formula for area of a trapezoid. Okay, if a trapezoid has bases of a units and b units long and a height of h units, then area A of the trapezoid is 1/2 times h times the quantity a plus b, or in symbols, it's simply area equals 1/2 h times quantity a plus b. Okay, so this is the area of our trapezoid. You need to memorize that. So let's find the trapezoid in example number 3. Okay, in example number 3, we know that the area formula is 1/2 h times the quantity a plus b. We substitute the values of a and b. So a and b would be 5 and 1/2 and 8 and 1/2. Okay, and that's what we did, substituting the values, and our height is 3 inches. Why is this our height? Because it is perpendicular to both our bases. Okay, so substituting the values and simplifying it, we now have 1/2 times 3 times 14, because 8 and 1/2 plus 5 and 1/2 will give you 14, and we simply multiply straight. 1/2 times 14 is 7, times 3 is 21, so the area of this particular trapezoid is 21 square inches. Okay, and let's take a look at the last example. Marissa works during the summer taking care of several of her neighbors' lawns. In addition to mowing, she also fertilizes the lawns. The label on the bag and the fertilizers that she will be using indicates that one bag fertilizes 2,000 square feet. Okay, so how much fertilizer should she buy for the yard shown below? So the yard is the one that has been shaded in taupe, teal, or something. Okay, so this is her yard right here. And to be able to find her yard, the yard is in the shape of a trapezoid. We all know that. The house and the driveway are rectangles. So this is the house and this is the driveway right here within the trapezoid that do not need fertilizer. So we don't need to put fertilizer on the house and the yard, obviously. We need to subtract the area of the rectangles from the area of the trapezoid to find the area that will be fertilized. So basically, to be able to find the area of the yard, which is this shaded region right here, it will be equal to the area of the lot, which is this whole thing, minus the area of the house, which is this one, this rectangle, minus the area of the driveway. That's what we want to find. And let's find each of them. Okay, so let's first find the area of a lot. So the area of a lot, again, is a trapezoid, so we follow the formula 1/2 h times the quantity a plus b. Substitute the values for height, which is 80, okay, multiplied by the quantity 100 plus 25. And if you notice, this is 80, that's our height. These are our two bases, 125 and 100 feet. Okay, simplify that. We have 1/2 times 80 times 225, or 9,000 square feet. Okay, so the area of the lot is 9,000 square feet. So again, using the formula right here, and we simply replace the values in the second step. Okay, and we use a calculator for this one. Well, probably not. Okay, so now let's find the area of the house. Area of the house is length times width. Okay, why? Because the area of the house is a rectangle. So if you notice, this is the area of our house right here. And length times width, we know that the length is 30 and the width is 24. So we substitute the values. Okay, we end up with the area of a house of 720 square feet. And let's find the area of a driveway. Again, it's a rectangle, so the formula is length times width. And if you look at our driveway, it has a width of 12 and it has a length of 50 feet. So we multiply 12 times 50, end up with the area, which is 600. Okay, now let's go back to this one. Area of the yard is equal to area of the lot minus area of the house minus area of the driveway, which is this one. So the area of the lot minus the area of the house minus the area of the driveway. Okay, so area of the lot is 9,000, area of the house is 720, area of the driveway is 600. So we simply substitute those values. We end up with 7,680. But we're not done. after finding the area of the yard, it says there that, okay, the label on the bag says that fertilizer she'll be using indicates that one bag fertilizes 2,000 square feet. So how many fertilizer bags should she buy for the yard shown? Okay, so what we need to do is we need to get the area to be fertilized is 7,680 feet. Since each bag fertilizers covers 2,000 feet, Marissa will need 7,680 divided by 2,000, or about 4 bags of fertilizer for the yard. Again, in this case, we need to round up, because if we round down, we won't have enough bags to fertilize the yard. Okay? The secret word for this particular lesson would be smart. The secret word is smart. Okay? Thank you for watching.